Howdy IB, it's Miss Kosh. I made a lovely video for this and then discovered that my audio wasn't working. So I'm pretty sure it's working now. We're about to find out. What I would like you to do is I would like you in just a second to pause the video and to work this first part out. Okay, none of this is new. I do want to make a video though, so that you know a few of the different highlights and the few different things that I want you to focus in on. But this first part, you can do, well, pause the video now and work at least through number 5. Okay. Okay. Did you pause the video? Pause the video. Go work 1 through 5. Okay, now we're back. And here is the answer key. So what we notice is that the tables, the x and the y values have changed. We have noticed also that f of g of x is equal to x and g of f of x is equal to x. This is what they call, and I wrote it down here, this is what they call an algebraic proof that they're inverses. If I can do the composition of the functions both ways, f of g and g of f, and both of those equal x, then I know that they're inverses. So I wrote it this way with the inverse notation down there. Okay, now the big point that I want you to take away here is that if I start with g, which is this one, and I find its inverse, well, the inverse of g is actually this, and that is not a function. Okay, so if they say, what is the inverse of g, then it's actually the plus or minus, the two pieces of that square root function. But if they say, what is the, so that's if they had said, if they say inverse, then you would actually, it would not be a function. If they say, is the inverse a function, you would say no. Now, if they say, what is the inverse function, and they use the notation g to the negative 1 of x, they could either say inverse function, or they could say this, the g to the negative 1 of x. If they do either of those things, then what that tells us is that we have restricted the domain on g to just being, we start at the vertex, and then we move in the positive direction. We could have gone in the negative direction, but all the math teachers got together. No, that's a joke. We just go in the positive direction. It makes more sense. And then that becomes its inverse function is just when we reflect the positive half from the vertex to positive infinity, and we reflect it over the line. It's over the line. Do you remember? Y equals x. Okay, so that's the difference there. So if they when they say, hang on, let me clear out some of this mess. When they say, find the domain of f and g, and so the domain of f and g were defined for you up here. So we can see that this is going to have a domain restriction because of the square root. We can see that this has no domain restriction on g. So the domain of g of x is going to be all reals, so from negative infinity to positive infinity. But if they had said, so those two came from here, they stood alone, everything is great and wonderful. But if they had said, what is the domain of the inverse of f? Now, the domain of the inverse of f is going to be the range of f. Okay? So if they start you with f, with something like, where was it? It was, okay. It was doing something like this. If they say, what's the domain of the inverse of f? Well, the inverse of f is now, if this was the point, -3, -5. I'm not really drawing it to scale. Then I need the point -5, positive, -3. I didn't say that correctly. What I wanted to say is that. Okay, we don't get to, if you saw me in class, I would be holding up my 2 arms to be a parabola, and then I'd put one down when we restrict the domain, and then I would have one arm kind of off to the side and flip that up. We don't get to grow an arm. If we start with this, and we take its inverse, we don't get to come and say, oh, look, I have this and this. No, that doesn't get to show up. That would be like growing an arm. You had one arm. Oh, well, dang it. Oh, there it goes. Okay, we had one arm right here that when we reflected it became, oh, that looks really terrible. But I hope you understand what point I'm trying to make. I just thought you should hear the bells because you're not on campus and you missed them, I'm sure. Okay, so we would need to, is the inverse of f of x equal to g of x? Well, sort of. We would need to restrict the domain of g so that it would be the inverse. Okay, and then is the inverse of g a function? No, not unless we restrict the domain. So is it a function? No. Can we write the inverse function? Yes, because we're implying that we've restricted the domain of the original. Hopefully that makes sense to you. I'm pretty sure I have videos for the rest of this, or some of it. Use my answer key that you have access to check, and then I'm pretty sure I have a video on the tricky ones. So this one was a little trickier, and this one is a little trickier. I know I have videos on those. Reach out to me if you need me to make a video on 1 and 4. Okay, good luck. Go practice. Let me know if you have any questions.